And welcome to the second part in this Alexa audio skills. In the first part, we just managed to stream one or play one piece of music across on our Alexa device. In this, we are going to add more music. I'm going to add the resume, next, previous, and start over intense. I've got a video of this in action, and here's the link, and I'll put all these links in the video to this. The code is all available on my GitHub site here, GitHub JLWork. So if you search for JLWork, you'll find the stuff that I've added, and this is in part 2 of these skills. So here's the first part that we did, and here's part 2 here. So we'll look at these a bit later on as we go through. So I've also got this script is also available there, and that's also this readme docx here. So let's get started then. So the first thing we're going to do is, because we're going to add these new intents, play, stop, resume. Some of these are already included, but let's have a look, just see. We're going to change the intent, so we're going to change the JSON, and the only thing I really change here is, apart from adding these, is to just add this start over and say things like start again, go to beginning, start over, and that sort of thing. So that will just take us back to the beginning of the track. This is an Alexa hosted skill, and I've got the code here, and we'll talk you through the code. So first thing I did then was I've changed the intents, and we can see the intents changed. If I go to the build tab, I've got it John's music box, and if we go to the interaction model and the JSON editor, then here we can see just the stuff that we've got, just copied and pasted. So if you want to do this, the best thing to do is just start with a new Alexa hosted skill and then cut and paste this JSON editor in, and then we'll show you what else. Cut and paste the intents into the JSON editor, and we'll just show you how we'll build up this code, what you need to do. So we'll go to the code tab again, and we'll look at this Lambda function in detail as we go on, as well as these other items. So as we did with the audio skill, the first thing we need to do is to upload some music. We need to remember the key or the URL for each, and we'll save the music data. We'll save that in a separate file called trackinfo.py, and I'll just show you what we've got here. So I've got if you click this tab here, this S3 storage, you'll get taken to your S3 management console, and that's what I've got here. I've got these, I've uploaded some more music this time, and you just upload your music by saying upload. And if we look at one of these, when you get it uploaded, you'll see what you'll need is the key, which is this key here, is what we'll need for each one. I'll talk a bit more about that as we go on. So let's see where we go on now. So I've created this file here, which has got, it's basically a dictionary, Python dictionary called trackinfo, and it's got 4 tracks in it, just to demonstrate what's going on. I've got a genre, I've got a title, I've got the artist, and I've got a URL. The URL is the most important thing here. And I've put those into a separate file called trackinfo.py, and here they are. Okay, so when you upload your music to your S3, you obviously can't use my music. Just remember to save the key, and that's what you put into this URL here. Okay, so that's the music uploaded, and we're going to access this, so we'll need to add a line that says import track as trackinfo at the top of the code. We're going to use persistence attributes. What they do is they save things persistently. Normally when you've got an Alexa skill running, you can just save it temporarily, but as soon as the Alexa skill is stopped, you lose that information. So we do that using persistent skills. And I've got a separate YouTube video on using persistent attributes. but I'll talk you through it here anyway. There's the reference to it. And we're going to store playback settings. So we're going to store a token, an offset, a URL, and an enqueued state. We'll show you why we need that in a minute. And the track number, which holds the current track being played. So to read those, you just basically say persistent attributes equal, and you get that from handler input attributes, manager persistent attributes. You can then read the track number or the offset in milliseconds. We'll talk a bit more about that in a bit. And then to save them, we just save our track number away. And then down here, we save these in by using handler input attributes manager save persistent attributes. I'm going to do that. Well, obviously they'll need to be set up initially, but I'm also going to use interceptors to load and save our persistent data. What the interceptors do is they intercept the requests coming in and the response going out and can modify what's going on. So when the request comes in, it loads the persistent attributes down, and when you send it out, the interceptors intercept the response and save the attributes. We'll look at that code, but it's basically here is the load persistent attributes. And here's somewhere down here is the save persistent attribute code. I'll talk about it now. So here we read the persistent attributes. If the length is 0, it's the first time we've ever done it. So we can set up the settings that we want. And I set up some Playback settings, token, offset in milliseconds, a URL, and a next stream include keys. I've also got a separate key. It's called the track number. So there's a little comment here. I don't actually do anything with this, but you might want to just look at this. This crops up if you look at the Alexa skills Python code on their GitHub. And for the save, all we do in the save is we just save the persistent attributes into the handler manager in persistent attributes and then do the save. So you don't actually need these, so long as every time you want them, you have to read them and save them away. To do that, we have to add some intercept code, and this all requires access to the DynamoDB table. So the next thing we need to do, we'll look at that code, how we add that code in a bit. But the next thing we need to do in our code is, because we need to access the DynamoDB table database to access our persistent attributes, we need to add those in our requirements. So we need to add this line here in our requirements. And if you're wondering about utils.py, what that actually does is that gets us a pre-signed URL so that we can access our S3 and our S3 objects from our code. Otherwise, anybody can access it. You don't want that. So just return to the Lambda function then. So we have to import the DynamoDB adapter. We've got to add these for the interceptors. We need a bit of a core builder somewhere as well. And down, all the way down at the bottom here, scroll. Most of this is fortunately boilerplate code. Here's our interceptors are added, load and the save. And here we add our custom skill builder for the DynamoDB adapter, which gets us access to the persistent attributes. You need to do that whether you have the interceptors or not. Okay, my session's just expired. Okay, I was going to show you how we get to the DynamoDB, but I can do that from here anyway. So if I go to the DynamoDB database, we don't need the S3 management anymore. And this is the one we want. So if I open this up, you can see our attributes and our playback settings are here. So here is, we've got these items: next streaming queued, offset in milliseconds, token, a URL, and our track number. These just happen to be the ones that were left as I got the last recording. So you can also see your devices in your DynamoDB database as well. Okay. So to access this, you have to add the references in the requirement.txt. You have to add all this code at the top for your DynamoDB to access the persistence. Remember, I've talked about this in another video anyway. Add the custom builder, and now you can get things like your track number and your playback settings. And then here is how we can see how to access our DynamoDB items and edit them if necessary. Okay, so let's look at the code that we're going to change now, that we're going to add. So the first thing I'm going to look at is the playback stopped handler. When the playback is stopped, that could either be via the Alexa device or the user. The user could just say stop, or the Alexa device itself might, get a notification coming in and say your Amazon delivery is available, which would stop your music. And then when it's stopped, you've just got to decide what you're going to do when it starts again. So we saw in our play, I'll come back to that in a minute, but we saw initially in our play handler, we just played it. This time round, we're going to have to check whether it was stopped and we not to resume it, or whether we're just starting from a normal play command. So in the playback stopped code, we get a response that includes, this is what we want, this offset in milliseconds. So what we need to do is we need to record that offset in milliseconds so we can start again from where we were interrupted, if that's what we want to do. And to do that, we need to read our persistent attributes and quite simply just save in our playback settings the offset in milliseconds, the information that we get from the handler input request envelope, and then we save them away again. I don't actually do the complete save because I save that when the interceptor when I send the response. But anyway, so all the playback stopped handler does then is basically just record the current playback in milliseconds. And I'll see whether we can find that in the code here somewhere, just to show you. And remember, a lot of this code we've already got just from the first time round, or gets developed, given to you when you create it, when you create your skill. That's the play. We'll look at that in a minute. Here's the stop, and remember all I said was, oh no, the stop is a command. We want the playback stopped. Here it is, playback stopped handler, and all we do is record the persistent attribute, the offset in milliseconds in our persistent attributes. Okay, so that deals with stopped. What we now need to do is look at the play. So remember, before we had a play command, and this ran when the user said something like play my music. So what we need to do now, though, is we need to know whether we came into the play, because we've got the user said resume, or the device itself resumed, or whether the command was given by the user to say play. And the way we can tell that is we've got an is intent name the play audio. So if it's the play audio, we just do exactly what we did last time. We're actually I start from 0. So that would be the first. So the first time, any time your user says play my music, it's going to start right from the beginning. You could modify that as a playlist or a shuffle, I suppose, if you want to, which is in more detail in the Alexa examples. I wanted this to be a simple example, but it seems to have grown a bit. And what we do, just to refresh then, in the play audio, what we do is we get an audio key, because we record the track number, from the track info track number, we get the URL. So we get, if it's track info 0, we would get the URL from there, and we would get remove and when playing you left all the water running. And then we save those away in the playback settings in our persistence, and we send a play directive, replace all, and we set the offset milliseconds in 0. So that's just starting from the beginning. Otherwise, the user didn't say play my music, and we come in here because we've got to resume, either from the user saying resume or that's the device itself resuming after an interruption. Like I said, it might be, I don't know, a timer timed out or something. But we do the same. We read the track number, we get an audio key from our track number URL, and we also use this create pre-signed URL from that audio key. Remember, that's just the URL. So that provides us with the URL, which we get from this utils here. And that's going to forget where I was now. And gives us resume and gives us access to our S3 device from this program. Save those away. I don't think I ever actually do anything with the token, but we do something with, I don't think I ever do anything with the URL, but I think we do something with the token. And again, we do send a play directive, replace all, but this time, because we're resuming, we get the offset in milliseconds from what we saved in our playback settings in our persistent attributes. So that's dealt with stopped. When you get a stop, you get a stopped handler. That saves the offset in milliseconds. When you get a play again, you either start from the beginning or you carry on with the resume. So that deals with the stopped and the play. I've just highlighted in this code what we need to do. Oh, just one other thing. We'll look at this in a minute. We'll see why we need to save this next streaming queued. Every time we do this, we'll set it to false, except in one case. So in the resume, we do the same. This time we don't actually change the next streaming queued, but it just saves as it was. Okay, so we now want to look at pause and resume. Well, actually, we've looked at resume, I suppose. And just to know here, the resume doesn't work correctly with echo dot. This caused me a lot of problems. All it ever does is just go back to the start of the track. So just reiterating, when the user says stop or pause, we get a playback stopped event occurring. This also occurs when the device itself does it. I think I'm just repeating what I've said before. So that's just a repeat. Would you believe it?